Now let's talk about some transformations that we can see in a quadratic function. If you remember back to first semester, we talked about transformations in a linear function, about how it can be compressed, it can be stretched, it can go up or down. Well, we're going to have the same thing with quadratic functions, plus a couple of other things. So first, your a value, that's going to tell you whether it's stretched, whether it's normal, or whether it's compressed. So if a is greater than 0 or greater than 1, it's going to be stretched. If it's equal to 1, then it's just normal. And if it's between 0 and 1, so it's a fraction between 0 and 1, it's going to be compressed. So let's see what that looks like. Here's my parent function, y equals x squared. If I were to put a number out in front that's bigger than 1, so let's say 5, I see that it's stretched. It gets more narrow. The bigger it gets, it just gets more and more narrow. However, if I have it compressed, let's say I did 1/2, I see it gets wider. Wider, wider, and wider. And so we're going to be calling that compressed. So for stretch, it can be said narrow, compressed, wide. Okay, and then your h that's in here, that's going to tell you how much the function moves to the right or left. So that x-coordinate of your vertex will tell you how much it goes to the right or to the left. So let's say if I were to put x plus 2, I see it moves to the left. Let's add a slider. If I were go to the other way, just moves it across that x-axis. And then the k is going to tell you how much the function moves up or down. So if it's bigger than 1, it's going to go up. If it's less than 1, it's going to go down. So always remember for this b1 that you're always doing the opposite. So you notice when b is negative 2, it's really going to the right. But when it's positive, it's really going to the left.